All right, we're going to be looking today at graphing linear inequalities in two variables. Remember again, a linear inequality is relating two different things using an inequality symbol. The graph of that is going to be a line which is either solid or dotted along with a shaded area. The boundary line splits that coordinate plane into two regions, what's not the answer and what is. The boundary line, if it's dotted, is not part of the solution. If the boundary line is solid, then any point on that line is part of the solution. And again, some helpful hints, just looking at where to shade. If the line is, if you see a greater than or equal to, we're shading above the line. If you see a less than or equal to, we're shading below the line. Any special cases as you look below, again, if you just have y and a number, or x and a number, then you're going to draw, if it's y, you're going to draw a line through that point on y, and then shade above or below, including your solid or dotted line. And then if it's x and a number only, then you would do the same thing. You would draw the line through that value of x, and then you would either do a solid or dotted line and then shade to the right for greater, left for less. And really on the y one, the special case, above and below still fits. Okay, so those are just some reminders, something to look at. Here on page 2, we're going to look at a couple of examples. One of those is in slope-intercept form. So as we look here for steps, it says graph the boundary line. It says use the slope and intercept. So the first thing we're going to do is plot the y-intercept, or the b. So if we look at our example over here, our b is going to be -4. So I'm going to put a dot at -4. All right, then it says use the slope to find a second point. Well, in this case, our slope is 2, which can be represented as 2 over 1. So it's rising 2 and running 1. So rising up 2 points, running 1. Rising 2, running 1. And then from that, I've got enough points, and I really only need 3, but if you don't have a ruler, the more points is better. The more points you can find, the better you are. Here, our symbol, if you look at it, says greater than or equal to. So that means that my line needs to be solid. So I'm going to draw a solid line that cuts through all those points, and it covers the entire part of the graph that I can see. Okay, so our solid line there, and then next we're going to shade the graph. And so our boundary line's solid because it's greater than or equal to, and then we're shading above the graph because it says greater than. So then my solution would be any point in this space along with any point on that line. So it's as simple as that. If it's in slope-intercept form, it's plotting the slope, or plotting the intercept, and then using the slope to find another point or two, and then drawing a line, solid or dotted, and then shading appropriately. At the end, if you're unsure about where to shade, you can always put a 0 and a 0 for x and y, as long as my graph doesn't go through the origin, or my line doesn't go through the origin. I can put a 0, 0. If 0, 0 is a true statement, I shade the side that 0, 0 is on. If I put 0 and 0 into my equation and it says false, then I would shade away from 0, 0. Okay, another situation might be that our equation's not in slope-intercept form. We can change it to slope-intercept form, or we could do what's done here. In this case, we have what's called an equation in standard form, an inequality, in standard form, ax, by, and a c. Okay, and so we can do a couple of things. We can make a table, or we can find the x and y intercept. I like finding the x and the y intercept. To do that, we're going to replace the other value with 0. So to find the y-intercept, I'm going to pretend like the x doesn't exist. So I'm going to say -3y is less than 6, and I'm going to solve. I'm going to divide by -3, divide by -3, and so then y becomes -2. Okay, so when x is 0, y is -2. And then I would do the same thing for x. So I would say -2x is less than 6. I would divide by -2. And so then x would be -3. So when x is -3, y is 0. So I would plot those 2 points, 0, -2, and then -3, 0. And those are the 2 points I need. All right, from there, I'm going to look at my symbol. It's a less than symbol, so I'm going to create a dotted line that goes through those points. Again, that dotted line is not part of the solution, but it creates a boundary. All right, now, what we need to do now is test a point. So again, because the graph doesn't go through 0, 0, I'm going to put that in there. So negative 2 times 0 minus 3 times 0, and see if that's less than 6. I can put that in my calculator, or I can just check it out. 2 times 0 is 0. Negative 3 times 0 is 0. Is 0 less than 6? Of course it is. So since that is a true statement, we're going to shade the 0, 0 side. Okay, because that test point was true, we shade above. If it said false, we would shade the opposite side. Anyway, I hope this helps. If you have any questions, let your teacher know.